Good evening, ladies and gentlemen. I am going to go ahead and do this video now, and hopefully it will be posted by the time you get home from school. So I can go kayaking this evening and to the concert tomorrow night and not have to worry about having this done. Anyway, next week, Monday, we will be talking about perfect squares and square roots. Perfect squares are numbers that are made, and you will have this vocabulary that you should have copied down already, are numbers that are made from numbers being multiplied together that are the same. So for example, if I have two factors that are the same, 1 times 1. We had the vocab the other day that these were factors. Yes, they're the parts of a multiplication problem. Equals 1. 1 is a perfect square. 2 times 2. Factor, factor. Same factor in the multiplication problem equals 4. 4 is a perfect square. 4 times 4. Factor duplicating. 4 times 4 is 16. 16 is a perfect square. It can be any number. Any integer times itself gives you a perfect square. 10 times 10 equals 100. 100 is a perfect square. So anytime you have a multiplication problem where the factors duplicate, then you end up with a perfect square. Perfect squares also make geometric squares, a shape, a geometric square. So if I had this geometric square and its one side was 4 inches, all the other sides have to be 4 inches. Yes? Yes. So this side would also be 4 inches. From elementary school, you know that area of a square, this inside amount of this square, is by doing its length times its width. Area of a square equals length times width. So the square root, a perfect square can be made into a geometric square if you fit the pieces together. So if I had, say, a 4x4, this 4x4 picture, and I made it up of little tiny blocks, and we're actually going to do this on Monday, so you actually get to build some of these geometric squares from perfect squares. There would be 16 little boxes making up this 4x4 box. These are called perfect squares. They're the numbers. But they can be translated into geometric squares. A picture of a square represents a perfect square. What perfect square depends on what its duplicating factor is. But a geometric square is made from a perfect square. We'll discuss that further on Monday. Going to square root. The symbol for square root looks like this. It's a division box with a little lip that hangs down. And inside that square root or radical sign, perfect squares are sometimes written. And when you see something like this, it's asking you, what is the square root of whatever is under that radical sign? Well, think about a tree or a plant. It starts with one root and then branches out. Well, when you look back here at these multiplication problems that make up a perfect square, the root is whatever that number is that you duplicate to make the perfect square. So if you look at the square root of 100, you multiply 10 by 10 to get 100. Yes? So the square root of 100 is 10. Make sense? Square root of 25. What number do you multiply by itself to get 25? Hopefully you're saying 5. The square root of 16. What number do you multiply by itself to get 16? Hopefully you're saying 4. the square root of 9. What number do you multiply by itself to get 9? Hopefully you're saying 3. Perfect squares, square roots. We'll be talking about, we'll do a hands-on activity on Monday looking at geometric squares, how perfect squares and geometric squares tie together. That is the video for the weekend, ladies and gentlemen. In under 5 minutes. Make sure you listen to it. If you didn't understand it the first time through, listen to it a couple more times. We will discuss it again on Monday. That will be where our lesson goes the beginning of the week next week. And hopefully by Thursday or Friday, you will be testing on exponents and perfect squares and square roots. Have a great weekend.